Okay, welcome back. Now, we've done a lot, and now I just would like to sort of recap the overall idea of standardizing and, what it means to look at standardized versus an original um, model from, from several hundred feet away, just to the overview of the big things. So, I have a little example here. Like to just go through the idea of units really and what it means. So we'll just go through these basic ideas and with an example from real estate, as you see as you're looking uh, at the notes here. So suppose we have an estimated regression model with two predictor variables. The response is y, and the predictors are x1, x2, and they're given down here. And this refers to the real estate data set from in Moodle. So y, the response is price, x1 is the building, the house square feet, and x2 is the number of bathrooms, and there's 522 rows. The original estimated regression function or fitted regression function is y equals little b0 plus b1 plus x1 plus little b2 x2, and that's right from the original data. And then the standardized one, b0 is 0, will be 0, should be 0, very close to 0, and so it's gone. So the standardized one is y star, and everything's starred, b1 star, x1 star plus b2 star, x2 star. Those are standardized. So what the idea here is the first one's clear, I think, what everything means. And it's a strange equation, really, if you step back and just think about it for a minute. You're taking a constant and you're taking something that is square feet and adding it to something that is a cardinal number, and you're getting something that's dollars. So, if you do physics, or something like that, you have different units. Must mean the B1s make the units equal out, but it's a little confusing. And what if you had even more? How do you really deal with this? So, it's the first thing to notice. The units are different for x1, x2, and y. Now, the standardized version, the idea is what are the units there? And what I would say is the unit of each variable, y star, x1 star, and x2 star, are standard deviations in that variable, in the original variable. So when y star increases by 1, that corresponds to y increasing by sy, one standard deviation. If x1 star decreases by 2, that means that corresponds to x1 decreasing by 2 s2 s1, or whatever I said, twice its standard deviation. So we'll see this in some detail now. And so if I do this, I first of all, I get these, just to remind you, I get the correlations. So just to remind you, so where y star is just equal to y minus y bar over sy. So, and then also 1 over square root n minus 1, and etc. So the same for the x's. x1 star, I should do one more, x1 minus x1 bar over, and remember this notation, this should be s1, 1 over square root n minus 1. So the etc. should be here. Okay. Now, with these set like this, we could just run the lm command to find the coefficients. So suppose we do that, and we find, so we would run something like lm y star. Once I set these, and I have x1 star plus x2 star, and we get, suppose this leads to the following for b1 star and b2 star, I get y star equals 0.7037, x1 star plus 0.1527, x2 star. Okay, and for comparison, well, let's start with this. So if you go by what I said before, I said each of these variables are now in units of standard deviations of the original variable. So y star, the units of y star are sy, okay, which is one standard deviation, i.e. one SD of the y variable. So I don't know what SD is, so, and you can, without even knowing the hard numbers now, you can think of things like, well, if there's a 1 standard deviation in this predictor variable, and that leads to a 3 standard deviation increase in the response, then that has a big effect, things like that. You don't have to talk about the exact numbers, where it may be challenging to do so, depending on the units. Okay, so we're there, and similarly, right, units of x1 star are sx, so it's whatever this, x1, it's whatever the units are of s1. So this is in units of dollars, right? So the units of y star, I would have to know what sy is. I actually do know what it is. The price is, it's $138,000 about. So the units of y star is $138,000. But I can just speak generally now and say the units of y star is 1 standard deviation of the price column. Okay, so it's in units of dollars still, but it's not single dollars. It's in chunks of $138,000, or in chunks of 1 standard deviation. Same with the other ones. So what did I write here? What does it say? Our sy, i.e. Okay, units of x1 star are s1, so, and that would be square feet. So 1 standard deviation, so etc., right? 1 standard deviation of the square feet, whatever that would be. Now, I did compute these, so just to give us an idea of what they are, we have sy, so this was done on the computer for this data set I had. Let me just round it. It's not perfectly rounded like this, but we will do this. So from the computer, S1 is 711, and S2 is about 1. So I'll put 1, it's actually 1.06 or something. I'll put 1.05. Okay, so this is about what the standard deviations are, and this is the units these are in the respective, what they are. Okay? All right, so now, what does it mean? So what does it mean now? So how do I read? So the next question is, I probably should have another piece of paper here. So the next question is, how do I read the regression function in the standardized variable? I say if x1 star increases by 1 unit, so for a 1 standard deviation increase in square footage, we get a 0.703 times 1 standard deviation increase in y star. Okay, so we can read this. We read the standardized regression function as, for example, a 1 SD increase in building square feet induces or results in a 0.7, so let's just say 0.703 SD increase in price. And the thing is, each SD refers to the SD of that vector. So knowing these SY and S1 and S2 here, so using, but you might not need those, so you might want to just talk in terms of standard deviations, but using the SY and S1 above, we see one standard deviation increase, roughly a 711 square foot increase in building size leads to a 0.703 times 138,000. It's about 95, maybe $95,000 increase in price. Okay, if we had computed the regular, like if I had done, so to compare, consider LM versus X1 plus X2, the original data, which gives me Y equals did I not do it? I didn't do it. Well, I had some B0 here, but I didn't write it down. So I have plus, but it doesn't really matter for this. Plus 137 X1 plus 19540 X2. Okay, so I didn't compute B0, but that's not really relevant to the discussion right now. So, and I can see if I have a 711 increase here, again, I have 711 times 137. This is the same thing. You can almost see the same numbers going on. Very close from the other data. It's very close because 137, right, is very close to SY here. 138, and 711 is very close to like 0.703 or whatever. But anyway, so to compare, if we consider this, we see a 711 square foot increase in price in X1, say, leads to a 137. It's going to be about the same thing. I don't have the, which is 137 times 711. This would be about 95,000. Yep. Increase in price. Okay, we'll do a little mathematical, little algebra proof of this fact that this is the right way to think of this, and these are the right shifts in, these are the units of the standardized regression model. Watch the next video.